Hi guys, let's look at the next chapter. The next chapter that we do is trigonometrical identities. So let's revise certain things and concepts that we did in class 9 related to trigonometry. So trigonometry is basically about measurement of triangles. In class 9th, we are looking at only a specific type of triangle, which is a right angle triangle. So this year also we'll be looking only at a right angle triangle. Trigonometry has 6 ratios that we basically work with. These are ratios of side. We give specific names to the side, and the names are dependent on which angle we are looking at. So for example, if I am looking at triangle ABC and I am referring to angle X, or in this case angle C, then for angle C or X, the side BC is known as the base and the side AB is known as the height. And obviously the side opposite 90 degree is known as hypotenuse. Some book and some people also refer to the base as adjacent, which in English would mean next to it, and height is referred to as opposite. Perfect. So this is the nomenclature. The side opposite the 90 degree obviously is hypotenuse. We are looking at reference for angle X. So for X, AB is the height or the opposite side, and BC is the base or the adjacent side. Now those 6 ratios are sine, cosine. Let's look at them one by one. So the first ratio is sine, written as sin, sine, and this is equal to opposite upon hypotenuse or perpendicular upon hypotenuse, whichever way you look at it, which means this is AB upon AC. Next, the second ratio is cosine, which is written as cos, which is basically adjacent upon hypotenuse, also base upon hypotenuse. In this question, it will be BC upon AC. And then the last one, which is tangent, which is written as tan, which is basically perpendicular upon base, also written as opposite upon adjacent. In this question, it will be AB upon BC. Perfect. Now what is SOHCAHTOA? SOHCAHTOA is sine is opposite upon hypotenuse, ka, which is cos, is adjacent upon hypotenuse, toa, t, is tangent opposite upon adjacent. So some people remember this as the acronym SOHCAHTOA. SOHCAHTOA. Next, some people also use OSHA chota, OSHA chota. So if you write OSHA chota, then it gets OSHACHOTA. OSHA chota, which is sine is opposite upon hypotenuse, cos is adjacent upon hypotenuse, and tan is opposite upon adjacent, whichever way you look at it. And then you have 3 more ratios, which are basically the reciprocal of the first 3 ratios that we talked about. So cosecant is the reciprocal of sine. So this is 1 upon sine, which means in this example, it will be AC upon AB. Perfect. Secant or sec is a 1 upon cos. This is a reciprocal of cos. And this is, in this example, would be AC upon BC. And then the last ratio is cotangent, which is written as cot, which is, in this example, it will be BC upon AB. Perfect. So I shared with you 2 ways of remembering the ratios, SOHCAHTOA or OSHA chota, and then there is one more, which is Pandit Badri Prasad Har Har Bole. So this is in Hindi, Pandit Badri Prasad Har Har Bole. The first one is sine, the second one is cos, and the third one is tan. Perfect. So you write Pandit Badri Prasad, and then below that you write Har Har Bole. Perfect. And then the second thing that we did last year was standard angles. So ratio of trigonometrical ratios of standard angles. These are the 5 standard angles: 0, 30, 45, 60 and 90. And then we realized and we figured out how to calculate those ratios. So I will quickly go over it. You write 0, 1, 2, 3, 4, divide everything by 4, and then eventually you take the square root of all of them. Perfect. So here I repeat, you write 0, 1, 2, 3, 4, divide everything by 4, and then take the square root. And then you write sine, cos and tan, and let's see what's the first one that you get. So 0 upon 4 is 0, so square root of 0 is 0. 1 upon root 4, that's 1 upon 2, so the sine is half. Next, this will be 1 upon 2, the square root, which means this will be 1 upon root 2. Similarly, this is root 3 upon 2, and then the last one is 1. So I need to remember one thing, which is 0, 1, 2, 3, 4, divide everything by 4, take a square root, and then whatever value comes will be the ratio for 0, 30, 45, 60 and 90. Next, to get cos, I write the same thing in reverse. So I started with 0 here. Now whatever numbers I've got, I'll write this in reverse. So which means 1 will come first. Next will be root 3 upon 2. The next would be 1 upon root 2. The next is half, and the last one is 0. And then I did not share one relationship with you. The relationship is tan theta is equal to sine theta upon cos theta. I forgot to mention this. So there is another special relationship, which is tan theta can be written as sine theta upon cos theta. So here, if you want to calculate the value of tan, you will divide sine by cos. So 0 divided by 1 gives me 0. Half divided by root 3 by 2 gives me 1 upon root 3. 1 by root 2 divided by 1 by root 2 is 1. Root 3 by 2 divided by 1 by 2 is root 3. And 1 divided by 0 is infinite or not defined. Perfect. So this is a quick revision of what we did last year. Let's look at the next thing. So last year we also talked about complementary angles. So ratio of complementary angles. This year this is not in your syllabus, but I'll take 1 minute to quickly revise what we've done last year. So sine of 90 minus theta is equal to cos theta. Cos of 90 minus theta is equal to sine theta, which means these are, if you have 90 minus theta, sine will become cos and cos will become sine. Tan becomes cot and cot becomes tan. So sine becomes cos, cos becomes sine, tan becomes cot, cot becomes tan. Cosec becomes sec, which is cosec is basically the reciprocal of sine. So this becomes sec, and sec becomes cosec. In this case, sec 90 minus theta is equal to cosec theta. Perfect. Now let's look at some new relationships that we will talk about this year. So new things that we're learning this year. So let's look at this specific example in which I have a right angle triangle ABC, where I'm looking at the reference angle as x. So let's calculate the value of sine x, cos x, and see if I can find a relationship. So sine x in this case would be perpendicular upon hypotenuse. In this case, it would be AB upon AC. Cos x would be base or adjacent upon hypotenuse. So this would be BC upon AC. Sine square x, which is basically sine x whole square, will be AB square upon AC square. And then cos square x would be the square of cos, which means BC square upon AC square. So I am now doing sine square x plus cos square x. So let's see, what do I get? I get AB square upon AC square plus BC square upon AC square. I'll take the LCM. The LCM is AC square. So this becomes AB square plus BC square upon AC square. Right? Yeah, the LCM in AB square plus BC square. Now this is equal to AB square plus BC square is equal to AC square. Why is AB square plus BC square is equal to AC square? Because since using Pythagoras theorem, hypotenuse square, in this case AC square, will be equal to the sum of square of the other two sides, which means AB square plus BC square. So since AC square is equal to AB square plus BC square, I write this here, which means this gets cancelled, which is what I get. Sine square x plus cos square x is equal to 1. So this is one of the most important identities of this chapter. What does identity mean? Identity means a value which remains constant with whatever value of x. So whatever is the value of x, my sine square x plus cos square x will always be equal to 1. So this chapter basically has three extremely important identities. The first one I just did with you. So I'll rewrite it. The first one is sine square theta plus cos square theta is equal to 1. Or is theta? Theta is basically any angle, measurement of any angle. So that's the first identity. The second identity is 1 plus tan square theta is equal to sec square theta. I'm not proving this, the proof is not in your syllabus, but if you just replace tan square in the left hand side with sine square upon cos square, you should be able to prove it on your own. Next, and the last one is 1 plus cot square theta is equal to cosec square theta. So these are the three most important identities in this chapter, which we will keep using again and again. So I repeat, sine square theta plus cos square theta is 1, 1 plus tan square theta is equal to sec square theta, and then the last one is 1 plus cot square theta is equal to cosec square theta. So let's look at the next one. So here, this question, or rather this chapter will basically have you to prove the following some certain identities. Like I have question 1 here, they want us to prove that the left hand side is equal to right hand side. Now to prove that, there are three specific methods. If you need to prove that left hand side is equal to right hand side, method 1 is you work with left hand side, do something to it so that you reach right hand side. This is a method which is approved by ICSE. Right? There is the second method. The second method says you start with right hand side, do something to it so that you reach left hand side. This is an approved method. And the third method is that you work on left hand side, do something to the left hand side, and let's say you reach value A. You work on right hand side, and let's say you have to reach value A again. Now since left hand side and right hand side are equal, which means this identity is true. So these are the three approved methods. You cannot start with assuming that this is true, which means you cannot look at cross multiplying. You can't look at taking right hand side to left hand side and using it as an equation. Only three approved methods are start with left hand side, reach right hand side. Second, start with right hand side, reach left hand side. Third, do something to the left hand side, reach a common value. Do something to right hand side, reach the same common value. Since these values are equal, which means left hand side and right hand side are equal. Now let's look at some questions. So I'm on question number 1, and here on the bottom right corner I have listed these three identities for our easy reference. Sine square A plus cos square A is equal to 1, 1 plus tan square A is equal to sec square A, and then the last one is 1 plus cot square A is equal to cosec square A. Perfect. So the next trick or the next skill here is to identify which side to start with. Should I start with left hand side or right hand side? So in my mind, what I usually do is I start with the complicated side. Whichever is the more complicated side is where I start, because breaking it into simple is easier compared from making a simple thing complicated. That's my assumption. So I always start with the complicated side first. So in question number 1, I feel left hand side is more complicated, and I also realize that on the right hand side I need to convert sec into cos. Is there a relationship that I know between sec and cos? Yes, the relationship that I know is sec theta is equal to 1 upon cos theta. Perfect. So now I know that if I just convert sec into cos, I should be able to reach my right hand side. So let's start. So sec A is equal to 1 upon cos A minus 1, and this is 1 upon cos A plus 1. We'll need to write the reason, since sec A is equal to 1 upon cos A. Now let's take the LCM and add this up. So left hand side is 1 minus cos A upon cos A, and this is a fraction divided by fraction, so let's multiply, which means cos A upon 1 plus cos A. This cos A and this cos A gets cancelled, which means I am left with 1 minus cos A upon 1 plus cos A. That's exactly what they wanted me to prove. So I have reached my right hand side. Perfect. So my work done, hence proved. Let's look at the next question. The next question is question number 3. Question number 3 says 1 upon tan A plus cot A is equal to cos A multiplied with sin A. That's what I need to prove. Again, like I said, I would try and work with a complicated side. So I feel this is more complicated than cos A into sin A. And I notice that they want me to convert the left hand side, which has tan and cot, into sin and cos, which means I will have to convert tan and cot into some relationship which has sin and cos. And I know that relationship because tan A is equal to sin upon cos. This is a relationship that I already know. And I know that cot is 1 upon tan. So let's substitute. So this will be 1 upon, instead of tan A, I get sin A upon cos A. And instead of cot A, I write cos A upon sin A. Now, since I'm working with the left hand side, so I should have written here left hand side. So left hand side is now, this is what I get. And the reason for this is since tan A is equal to sin A upon cos A and cot A is equal to 1 upon tan A. This is the relationship that I used, and that's why I have substituted this value. Now again, let me take LCM and try and add. So I get 1 is in the numerator, this becomes sin square A, and this becomes plus cos square A, and my LCM was sin A into cos A. Yes, now this is fractional division, which means my answer becomes sin A dot cos A upon sin square A plus cos square A. Now I remember the first identity that we proved, sin square A plus cos square is equal to 1, which means this is equal to sin A into cos A upon 1. The reason being, since sin square A plus cos square A is equal to 1. So this becomes equal to sin A dot cos A dot basically means multiplication sign. So this is equal to the right hand side. So this is what I needed to, where I needed to reach. So hence proved. Perfect. So thank you so much. I'll see you with the next video. Bye bye. Take care. Be safe.